So given this triangle and this particular angle that we have identified, and we have measurements all across, can we determine the six trigonometric functions of this particular angle? Now, a little bit of the definition. Notice that I have the vertexes all labeled with a capital letter. And notice the side opposite the vertex I have labeled with its lowercase letter. Just a little bit of a standard way that we do that. I have both of the base of the legs. One base is 12, or one leg is 12, and the other leg is 5. And then I have the hypotenuse, which I do not know. So, how do we determine these functions? Well, first of all, we need to have measurements of all three sides. C is unknown. Fortunately, we remember our good friend Pythagoras that says one side squared plus another side squared equals the third side squared. So if I had 5 squared plus 12 squared, that should equal C squared. 5 squared is 25 plus 149, or 144, excuse me, equals 169. And then take the square root of 169, and that's going to equal 13. So 5 squared plus 12 squared equals 13 squared. That tells me then my other side up here, which I did not know, but I had to configure, is 13. Now I have all the sides available to me, so I can go through and use these trigonometric functions to determine what's the different measures of this angle. So the sine function of this angle, sine is, do you remember, opposite over hypotenuse. So what's the opposite of this angle? It's on the other side. So that's 5 over hypotenuse, which is 13. So the sine of theta is 5/13. The cosine of theta equals adjacent over hypotenuse, which is 12 over 13. The tangent of theta, again, these functions are just ratios of one length versus another length. So the ratio of tangent is the opposite over the adjacent, which is 5/12. So we got 3 of them done. Let's do the other 3. The cosecant, that was hypotenuse, which is 13, over opposite. The secant is hypotenuse over adjacent, which is 12. I put opposite on that one. That's a 5, isn't it? And then the last one, the tangent. The tangent's pair is a cotangent. And based on our definition, the tangent is the relationship or the ratio of the adjacent side versus the opposite side, which in the case is a 5. So there are the 6 trigonometric measurements of this particular triangle whose sides measure 5, 12, and 13. Another example here, we have another triangle. We want to develop all 6 of the trigonometric functions based on our angle theta. Notice that we're given the length of the hypotenuse this time, but not one of the lengths of the sides. So how do we determine the side that's unknown? We go back again, use our friend Pythagoras, which says that one side plus the other side equals the third side, or the hypotenuse, squared. All those are squareds. Sorry, it's 3 squared. Solve that for b. So b squared equals 9 minus 1, which is an 8. Take the square root of both sides, and b equals 2 square root of 2. And now that I know that, I'm going to put it up here. So I have that marked and available with me. Now, if you don't remember how I converted 8 to 2 square root of 2, I encourage you to go back and review some notes that you may have picked up in a previous course, or look at one of my previous videos to help you understand how you can convert a square root number and simplify a square root, or scriptify a root. Right, now that we're given all the sides, we have enough information to continue. So our sine of theta equals, do you remember yet? Opposite over hypotenuse. Or yeah, opposite over hypotenuse, so that's 1 over 3. Cosine of theta is adjacent over hypotenuse, which is 2 root 2 over 3. Tangent is opposite over adjacent, so that's 1 over 2 root 2. Cosecant equals hypotenuse over adjacent, 3 over 1, or just a 3. Secant of theta, 3 over 2 root 2. And then our cotangent, which is adjacent over hypotenuse. Adjacent is 2 root 2, all over a 1, or just a 2 root 2. So those are the values of these 6 trigonometric functions, the basic 6 that we'll continue to learn with. Notice a couple things though, as I reduce these down and solve these, I have 2 issues. This one and this one. You guys probably realize, wait a minute, Willie, those aren't reduced because we have a radical in the denominator. So we should rationalize those to get to its pure form. So remember how we rationalize? Well, let's practice on this one right here. I need to multiply by a clever version of 1 so that the radicals in the denominator are eliminated. And the one I'm going to choose is a root 2 over root 2. Multiplying that through, my denominator is a root 2, and my denominator is a 2 times root 2 times root 2. Root 2 times root 2 is a 2, so I have 2 times a 2. I'm left with a 4. So the tangent of theta in this particular case is root 2 over 4. That's the proper form. Likewise with the secant of theta, I will have to rationalize its denominator as well. And you want me to do it now? I kind of want to. It felt kind of fun. So at 3, okay, that's the secant. I'm going to multiply again both sides by root 2 over root 2. That's my clever version of 1. Multiply through, I'll have a 3 root 2 all over a 4. And there's my value right there. So there's my secant. And this one was my tangent. Hey, it's good to remember some of the skills we've learned in prior courses and prior opportunities as we do that. Again, the purpose of this is to help us realize that triangles can be measured in different types of ways. That's what trigonometry is, the measurement within triangles. And we see that triangles have these relationships between corresponding sides. And there's 6 total sides that correspond with each other, which gives us 6 trigonometric functions.